Good day, detectives. I am Weather Detective Jim.
And I am Weather Detective Kayla, and today we are sitting down to give you our forecast. We saw in the comments of the last video what you guys think this weather event is and whether you think we should warn the public, but today we are sitting down to go through the clues ourselves and give our forecast and let you know whether we think we should warn the public and what the weather event actually is.
But before we get started, I gotta clean my glasses. Hold on a second. Okay, I think we're ready. Okay, are we ready?
Let's jump into clue number 1 and see what's happening at the upper levels. So we are looking at the 250 millibar level. Unfortunately, communications not doing too hot. Ink blots are covering up the date and time. So do we actually know what's happening? We don't, but there's a lot of information that we can glean from this one map, namely being the jet stream. Where is it? What does this have to do with this certain weather event? Can we tell what season we're in?
Taking a look at it, we can see the actual flow. There's contours of higher wind velocities that are shaded in various colors of blue.
Yep.
And we actually have the wind barbs on there. So looking at this, looking at the US is the background geographical map. So kind of going, well, for a jet stream to be coming in that strong off the Pacific and actually looping down into Texas and Mexico and going back up to the Northeast, that to me instantly kind of leads me more toward a wintertime event than, say, a summertime event. And especially with the winds being that strong. So yes. 250 millibars, we're somewhere up in the 30,000 plus foot range. When you see those, the wind barbs, for those that are not familiar, when you're looking at the wind barbs, you see a little flag and then you see little lines. Well, each flag is 50 knots and each wind barb line, full line, is 10 knots, and a half of a line is 5 knots. Yep. So when we're looking at this, I see a lot of 90, 100, 110 knot
that one's
wind
130.
barbs. Exactly. So it indicates to me that you have high temperature contrasts, etc., etc. So I'm leaning more toward a cold season event here.
Cold season event. Now let's go on to the mid-level map clue that we were given and see what we can glean from that one.
And again, unfortunately, we had outages, so our Difax map for all you oldies out there, all of us oldies, right? Looking at our Difax map, we unfortunately don't have a date or time, but we do have 500 millibar level, which is about 18,000 feet roughly. So in the mid-levels, we do still see a carving out from west to east, full latitude trough that is occurring there in the middle part of the country. So you have winds coming out of the northwest on the western side and winds curving around and going toward the northeast on the eastern side. Again, wind barbs showing very strong winds at that level.
Still at the mid-level, yeah. For the winds to be screaming that much at the mid-levels, it's quite the weather event that we're looking at here.
And things are stacking up. Underneath the 250 millibar layer, at the 500 millibar layer, you have basically rotation and trophiness basically stacking up.
Is that
over
a word?
top.
Is that a word? Trophiness?
Trophiness.
Okay.
Yes, that's right.
The
so
trophiness happening. But we are also told to look for the low pressure systems and where they might be to give us an indication of maybe some hot spots on this US map. So where are the low pressure systems?
That's right. So taking a look at the 500 millibar layer, we see that there is cyclonic rotation up over the Great Lakes area as well as down over the Oklahoma and Texas region. But where is the trough at the 500 millibar layer? And we see that it extends through the southern plains, through Oklahoma and into Texas and down into Mexico. So the area of interest that I focus on at this point is at and to the right of that line. So anywhere from the Great Lakes on down into Texas and over to the East Coast, that's my area of focus just with these two maps right now.
Yeah, the low pressure systems and the troughs are a great indication of where you can have upper level divergence, where you can have rising motion. So these are kind of hot spots where if we're looking for precipitation type events or anything severe or weather that's basically the opposite of your bright sunny day, these are the locations on this map specifically where that would be occurring. So something to keep an eye on as we go to our next map, which is a surface map. Down at the surface, we again don't know where we are, but we do know that this is a 12Z surface analysis. So this would be around 7 o'clock in the morning, depending on your time zone, but we're looking at early morning here. And on surface maps specifically, we are going to be paying attention to fronts, boundaries, temperatures, dew points, also keeping in mind those hot spots that we saw on the first two sets of maps.
That's right. So when we take a look at our surface map, again, we had those two areas of low pressure over the Great Lakes, and we also had the mid-level low pressure down over the Oklahoma-Texas area. Taking a look at the surface map, I see an area of strong high pressure over Minnesota. Yes, there might be mid-level rotation and troughiness over the Great Lakes, but high pressure is in control there. I don't really see a lot going on, so my attention now starts to focus more over Texas, Oklahoma. Let's see what's going on there. Again, high pressure has basically given Texas a blue norther, and there's the front is off into the Gulf of America.
Okay.
At the time that this event was occurring, it was the Gulf of Mexico. So taking a look at that, I see low pressure has formed along a stationary boundary. The thing that really got me on this one, take a look at the temperature contrast across this front. When you look to the south and east part of the front, you see temperatures in the 70s. And when you look to the north and the west, you see temperatures in the 40s. And going back over Texas, you see much colder temperatures back behind that front. So there is a very, very strong contrast between what the buoys are showing off of Louisiana and over Texas, the mainland Texas there.
And those temperature contrasts can lead to a couple different things in addition to the temperatures themselves. When you have such a strong contrast, you're going to get very fast moving winds as the atmosphere tries to balance out the really cold here and the really warm here. Now we have shifted our focus more towards where the cold air is over the Great Plains, but we do also have a front over Florida, and Florida was one of the areas that we were going to be keeping an eye on because it was east of that trough that we saw in the last one. So at this point, could something still be happening in Florida?
Absolutely. Absolutely. Just follow that stationary front track. I see an area of low pressure off of Tampa Bay. I see an area of low pressure south of Louisiana. Definitely an area of interest in that Gulf Coast region.
So let's keep that in mind and move on to map number 4.
The next image that we have here is a SCUT log P diagram. And for those that are not familiar, this is your first weather detective. This is what we look at from a vertical perspective. On the bottom of the image is the surface, and then as you go up on the image, you go higher in the atmosphere. It's got a bunch of different lines on it. Specifically for our weather detective today, you do notice that there is a thicker blue line. That is our freezing line, 0 degrees centigrade, 32 degrees Fahrenheit. It is skewed. It doesn't go directly up. It is skewed. That's why it's a skewed temperature logarithmic pressure chart. As we take a look at this, you'll see two different squiggle lines on the left side. The leftmost squiggle line is the dew point temperature, and the rightmost squiggle line is the temperature. So you launch a balloon, you have sensors on there. One thing's measuring temperature, the other is measuring how much moisture is in the air. From that, you can calculate the dew point. As we're looking here, we see the entire column, what we say in meteorology, the entire atmospheric column when this balloon was launched, everything is below freezing. You see, it's to the left of the 0 degree C line. So therefore, this looks to me, specifically this station here, and it's tied into the event that we're trying to figure out.
Yes, this comes from where the event is occurring. We just don't know where because, again, communications have blocked off. We're having issues. The fax machine is malfunctioning. This is what we're given, but this is from where the event is happening.
That's right. So that leads me definitely to believe it is a wintertime event. The whole thermal profile is below freezing. Very
much so there at the very surface. My
That's
goodness.
Right. Very, very cold air. We call that an inversion, where you've actually got cold air, and then as that balloon goes up, it's measuring warmer and warmer temperatures between that 900 and 700 millibar layer. So we call that a temperature inversion in meteorology, so which basically is just big words to say the temperature got warmer as you went up. Typically, temperature gets cooler as you go up. As you probably experienced if you've climbed a mountain, you've noticed that it's warm down at the surface, and then as you climb the mountain, it gets colder. Same principle here. So that's what I see when looking at this thermal profile. What else do you see with this?
So this is a great image to look at to tell convective available potential energy, which is CAPE, if you're familiar with that. It's a value that we look at specifically in trying to figure out severe weather and how much potential energy there is in the atmosphere that could fire off storms. Now, again, this specific image has come to us from where our event is taking place. And if we look at the right side there, it gives us a ton of different values that the balloon has measured as it went up in the atmosphere, one of those being CAPE. And here we see the CAPE value is actually 0. So nothing's going on.
So that means
nothing exciting severe-wise is happening in the sense of thunderstorms, tornadoes, lightning, hail. We're not looking at one of those types of events. Otherwise, we would see CAPE values higher. On the left side there, we do have it listed out what kind of CAPE values we're looking at for specific events. So like weak instability, stronger instability, you can see the numbers there. And we typically want to see that in the thousands range if we're looking for some sort of severe weather. Ours being 0, our main clue from this map is going to be how cold the profile of the atmosphere is.
One other thing that we can take a look at with this thermal profile, and that is the temperature and dew point. Remember the squiggly lines? When they're closer together, the higher the relative humidity. So when they're very close together, that humidity is 90, 95, 100%. So that could indicate precipitation, and anything where the relative humidity value is, say, greater than 70%, you can assume that that is where cloudy areas are. As you're looking at this, it definitely looks like there's a lot of moisture in place in the lower layers of the atmosphere.
Yeah, so this might also be telling us that there's a chance that currently, at whatever time this was taken, it's precipitating. And if it is precipitating, it should be winter weather.
Now, Kayla,
yes?
Do we have a video out there that talks about thermal profiles and what kind of precipitation falls from a typical profile? The warm nose, things along those lines. Editing Kayla can put a link in the description that if you're interested in seeing, gee, what kind of precipitation could we expect? Is it going to be rain, freezing rain, sleet, snow? That video will definitely describe all those concepts.
Yes, so I will leave that linked down in the description box if you're interested in diving more into skew-Ts and how to tell what kind of precipitation would be falling from the sky based on profiles such as this.
So now let's take a look at the next image, and this next one is actually the convective outlook from the Storm Prediction Center.
It is! And as we can tell from this map and our clue asking where the highest risk is, that area of interest that we were talking about over Florida was actually picked up on this day by SPC. So they are looking at some form of convective event, that's a big word for saying thunderstorms, potentially other things that we'll step through here in a second, over the Florida Panhandle getting into Georgia. So a definite area of interest for SPC on this day. We noticed there's nothing over in Texas where we were looking as our second area of interest, but based on the skew-T that was telling us the CAPE value is 0, we can pretty much rule out wherever SPC is talking about thunderstorms for our event specifically. And stepping through real quick through the tornado outlook, the hail outlook, and the wind outlook, everything is over that southeast, mostly Florida Panhandle area. Something convective is going on. Looks like there's a chance of hail, tornado, and wind in that area. Again, with our skew-T telling us that the CAPE value is 0 and our temperature profile being all in the freezing, this is an area that we will no longer be looking at for our event specifically.
And to follow up with that and supplement that information, if we go back to the surface analysis to determine whether our event that we're looking for this weather detective, is it Florida and severe weather based, we had the skew-T where everything was below freezing.
Yep.
So if we look at that surface weather analysis map and we look at Florida, even the Panhandle, Pensacola, is reporting a temperature that's that red number in the station plot of 49. So that is well above freezing, which is well above where our skew-T profile was. And then anywhere south and east of that through Florida, you're getting into the 50s, 60s, and 70s.
Right.
So for this specific event here and that thermal profile, because we know that's where the weather event is taking place, we can eliminate Florida from our area of interest.
Lastly, for our clues, clue number 9 is a sea surface temperature map. So we will be looking at the sea surface temperatures here in North America, South America, the Atlantic, and part of the Pacific.
Taking a look at the color coding, we can see at the legend at the bottom, the bluer shades are 20 degrees C or less. 20 degrees C is 68 degrees Fahrenheit, and anything in the green shade or warmer is above 68 degrees. Now, if you think anything tropical in nature, we like to see temperatures at or above 25, 26, 27 degrees C. You're looking in the upper 70s, definitely 80 degrees Fahrenheit and warmer. But looking in that general area right off the Texas-Louisiana coast, it is definitely much cooler than that. So we are not looking at a tropical event. We are definitely looking at more of a wintertime event. Now let's get into our trusty fax machine.
3 weather detectives in, we have not replaced our fax machine. Lo and behold, the outages and communications issues have given us this document with ink splotches and ripped paper all over it, and we have to glean what information we can from what is legible. And one of the things that is legible at the top, this is from the Storm Prediction Center. It is a mesoscale discussion. So we are talking about a small area of interest somewhere in the United States that SPC has deemed hazardous enough that we are going to put together a full report here, and let's look into it and see what exactly this might be concerning.
Of course, I don't have my glasses on, so I gotta kind of lean in a little bit, so bear with me.
You wanna use
Oh
these?
yes, yeah. I'll use mine. So there's wording in here that talks about a 3 to 5 a.m. time period, so we know we're in a wintertime event, and we know it's overnight, so we don't have any heating from the sun, so we know this is definitely cold. There's words of heavy, and then there's a blank. I'm leaning more towards, since it's below freezing, we're talking either snow, sleet, or freezing rain. As we go through this, we see it talks about model guidance and talking about a corridor of where this banding could set up. Usually when we talk about those kind of things, we tend to use more of that kind of wording for frozen precipitation or freezing precipitation. Dangerously something temperatures, I'm gonna probably fill in the blank here, say dangerously cold temperatures. As we looked at the SCUT, I mean the temperatures were down in the -10 to -20 degrees C just at the surface. So you're talking, well, -10 is what, 23 Fahrenheit, -20 is, do I have my numbers right? I don't think, no, my numbers are not right. -10 degrees C is 14, and -20 is down around 0. So if I did my math correctly, for every 5 you drop 9 on the Fahrenheit. Either way, it's very cold.
Dad's doing quick math over here.
Very cold.
Cold temperatures.
And speaking of cold, I'm coming off of a very bad cold, so my head is not completely there. I'm trying my best. If you're still with us, thank you so much. We appreciate it.
Dad has a bad cold. Somewhere in the United States has a bad cold.
That's right. That's right. And we just keep looking here, and it talks about additional amounts. It looks like road conditions worse. Usually you don't really say a whole lot of that with heavy rain other than a flooding event, but this doesn't look like a flooding event.
No.
So definitely some sort of accumulating precipitation, and then windy conditions on top of that. As we continue to look, it becomes more obvious that we're talking about heavy snow or heavy ice accumulation.
Right.
We're talking about dangerous wind chills, possibly.
Hazardous, dangerous,
dangerous,
single digits.
Significant, all these words coming together that just scream of a very big wintertime event.
Yeah, and this one specifically, pipes bursting, power grid stress, your cars might not start if they're outside, all things that are leaning into that snow or ice in addition to very cold temperatures type event.
So let's answer the questions. The first one being, when does this event take place? It takes place in the wintertime.
Yep.
Which states will be impacted?
So I will be looking at Texas specifically based on the maps that we have and kind of how that's all lined up with what we saw in the surface maps and the SCUT and so on. But it could also be into Oklahoma or even a little bit east of that and north as well.
Yeah, definitely, because that surface low pressure area, you have moisture from the Gulf of Mexico, Gulf of America, throwing it back into Louisiana, Texas area, and then you still have in the upper levels that trough is still back further over Texas, so there's ample moisture in the lower layers of the atmosphere underneath that, along with divergence from the jet causing significant rising motion. So definitely that area, the Texas, the lower Gulf Coast. What is the main weather threat, and should we warn the public?
You're gonna have dangerous cold. There's talk of snow and ice. Travel is highly discouraged. They're talking about stress on power grids and stuff. This does not seem like the type of event that we would not warn for. So I would say definitely this needs to be something sent out to the public ASAP, warn them of what is happening, and that would be a winter storm event. Alright, so now the part of Weather Detective that everybody is waiting for. Is this forecast correct? Is your forecast correct? What could it be? Cold event, Texas. Ta-da! So looking at this, we still don't have an exact name, but we're looking at, yes, it's cold, it's freezing, it's talking about heavy snow, heavy ice, I-20 corridor. Let's head over to our SKU-T real quick, and we have the information that we have been looking for. 12Z, February 15th, 2021, and specifically for a lot of these images, it was taken from Fort Worth, Texas. This was known as the Valentine's Day snow event. A couple facts about this event: at one point the entire state of Texas was below freezing, but you can see from that surface map, the front went all the way down into Mexico. It was just an insane weather system that came through, pushing so much cold air, a lot of heavy snow and ice. This was also occurring across other states in the area as well. At one point, every single county in the state of Texas was under a winter storm warning. Just insane winter weather event that happened here a few years ago.
And for those that don't realize, maybe you're not from the US, Texas is huge. So to have every single county under a winter storm warning.
And Texas also is in the southern United States. It borders Mexico. For all of Texas to be under a winter storm warning, absolutely crazy event. So there you have it. Weather Detective Case 3 has been solved. Let us know down in the comments, did you get it right? Were you on track with the winter event? Let us know if you enjoy these types of videos, and we would love to continue doing them. We have a little bit of a list of some ones that we want to do in the future. Again, as always, if you like what you saw, be sure to leave a like, subscribe down below, follow us over on social media, Facebook and Instagram. Check out School of Weather. It is the top link in the description box. Down there you will also find a little bit more information about this event if you got through this video and were still curious about the Valentine's Day Texas freezing event. We will link down below what the National Weather Service had to say about this event so you can read about it after you finish watching this one. Until next time, I'm Weather Detective Kayla.
And I'm Weather Detective Jim.
Thanks for watching.
And we'll see you at the next case.